Okay, so for the next couple lessons, we'll go back to topics you learned last year in AB and then supplement them with the BC topics that were skipped. First, chapter 6, differential equations, and from section 6.1, Euler's method. Okay, so take a minute if you want to write these things down. A differential equation is an equation involving x, y, and the derivatives of y. Okay, differential for sure, the derivative. We look at 4 different types of solutions. The graphical solution with slope fields. You learned that last year. We'll do it again this year. Analytical is your actual method of finding an antiderivative. We talked about general versus particular solutions. Verbal, writing a differential equation to model a given situation. And then one of several numerical approaches is Euler's method, and that approximates the particular solution of a differential equation. Okay, so y prime equals big F of x, y through a given point. Now, differential equations we know can be in terms of both x and y, so that's why you'll see the derivative written as the antiderivative, and it can be in terms of x and y. Okay, so to use or apply Euler's method, you need your derivative, you need a point on the solution curve. This will serve as our starting point for the approximation. We need some small step that we will use to approximate, and then we need to have a certain number of iterations that we'll use in order to get to the final approximation. All right, the method is tedious. The AP graders suggest that you create a table to keep yourself organized. You don't have to put a table necessarily, but all of the calculations need to be shown. Generally, these are non-calculator problems. So the example we're going to do now is very tedious, but for the most part on your AP test, you won't ever have to do this many. But okay, so this is what we're approximating, x sub m, y sub m. Before we start, this is our initial condition. Okay, so I shouldn't say initial condition. Yeah, that's what it would be. The point would be x sub 0, y sub 0. Oh, sorry about that. Your x values are very simple. Okay, the x coordinates of your approximations, we just take the previous value and add that h to it. Remember, h is how far we're moving to approximate. So the x coordinate, very simple to do. It's the y coordinate that you could get a little bit lost. So notice that in order to get the next approximation, it's always based on the previous point. Okay, so to get your first y value, we take our previous y value, the y coordinate of our starting point, and we add that to that h, okay, that value or the step that we're using to approximate, times the value of the derivative at the previous point. Okay, so it's going to be a little bit of substituting because we're going to have to take that value and plug it into the derivative. Okay, so to get the second y coordinate, notice that we're using the information from the previous point. And then this is just in terms of n. Okay, notice the n minus 1, that means we take the previous value. Okay, so use Euler's method to make a table of values for the approximate solution. So here's my differential equation. Okay, this is my starting value. This is how many approximations I'm using, and this is the step size. So we're going to have 10 approximations, each of a unit of 1/10. Now notice if I multiply these, then where am I going to end? If I start at x is equal to 0, I'm going to end at x is equal to 1. Okay, because we're taking 10 steps of size 1/10 to approximate the solution. So we're approximating the solution. So we're approximating y sub 1 is going to be equal to what value? Okay, so if you want to set up a table of values just to attempt to keep yourself organized. And I'm going to fill in as we go. Starting point 0, 2. So h is just equal to 0.1. X sub 1 is just going to be 0.1. Okay, x sub 2 is going to be 0.2. We just continually add h. They're the easy ones. So my y value, y sub 1, it comes from the y coordinate of the starting point plus h times the value of the derivative. So my derivative was x plus y. All right, so plugging in 0 plus 2, that would give me the value of my derivative at the point 0, 2 is 2. So 2 plus 0.2, so my y coordinate would be 2.2. Seemingly simple. So now my second y coordinate, I take the y coordinate of the first approximation, I add to it h times the value of my derivative from the previous point. So remember my differential equation is just x plus y. So I take my x coordinate, I add it to my y coordinate, and this would be the value of the derivative. So 2.2 plus 0.1 times 2.3. And again, these are non-calculator, okay? I'm multiplying by a tenth. So each derivative, we just move the decimal to the left one place. So 0.23. And now that gives me a y coordinate of 2.43. Okay. Now remember, we got to get all the way up to 10. Okay. And this answer here will be your approximation of y sub 1. Okay. So, like I said, pretty tedious. Y sub 3, I take my previous y coordinate, the value of my step, and then I add my x and my y coordinate together. And it won't always be this easy. It all depends on what your differential equation is. Our differential equation here is just add the x and the y values. Sometimes you multiply. Maybe we would have to divide by another value. But this one, the derivative is simple enough to manipulate. 2.43 plus 0.1, and I have 2.63. 2.43, move the decimal to the left one place. Adding those together, I get a y coordinate of 2.693. So my third approximation, 2.693. Okay, so think about what we're doing. If we're looking at the graph, then these are the coordinates of the points as we travel up to where the x coordinate is 1. Okay, so we started at 0, we're heading in the direction of 1, and we're getting there by taking 1/10 of a step each time. So y sub 4, my y coordinate for my third approximation, h, the value of the derivative, I'm going to add that 2.693 and the 0.3. 2.693 plus 0.2993. All right, add those together and then move the decimal to the left one place. So now when you add these, let me show you. Okay. 19, 9. Now this is where it gets a little tricky. For the AP test, 3 decimal places is all we need to approximate. But according to the solution, when you go to find y sub 5, you should be using this entire approximation. So in the table, I'm going to write it as 2.992. But when I go to find my fifth y value, I'm going to use the whole decimal, the 2.9923. I'll check for you to see if you would need to do that. But again, on the AP test, you're not doing 10 steps, okay? It's too time consuming and tedious to have it at this length. But let's just finish the fifth. 0.1. Take the original decimal. Add to that your 0.4. So 2.9923 plus 0.1. And now when we add 0.4 to this, 3.3923. Move the decimal to the left one, please. And now when I add these together, I get 3.33153. So when I then take this decimal and I round it to 3 decimal places, in my table I would put 3.332. Okay, so for your homework, finish the approximation for y of 1. Okay, so finish your 6th, 7th, 8th, 9th, and then your 10th will be your answer. Finish that tonight.